Okay, so we're going to take a look at a question. This question comes from a linearity course, so this would be a course in linearity or algebra. So we're told to let capital X equal to x1, x2, x3 included in R3, such that x1 plus x2 plus x3 is equal to 0. We are asked, is capital X a subspace of R3? So what we need for this to be a subspace is we need three conditions. We need a zero vector. We need two more conditions. We need this to be closed under addition. Closed under addition. And the third thing we need is closure under scalar multiplication. So we need this to be closed under scalar multiplication. So let's do one at a time. So we'll start with 1. And if we have all three of these, then it is true that capital X is a subset of R3. If we don't have all three of these, then it's not. So we've got, for 1, do we have a 0 vector? Well, this will be 0, 0, 0. So 0, 0, 0 is the 0 vector. This would imply that x1 is 0. And this is also equal to x2, and this is also equal to x3. So 0 plus 0 plus 0 is 0. This is true. And so therefore the 0 vector satisfies the condition on this subset, so therefore we do have a 0 vector. So now let's check for closure under addition. So we're going to take two vectors. We're going to call the vectors u, which will be equal to, let's say, alpha 1, alpha 2, alpha 3. And then we're going to take v, and this will be equal to beta 1, beta 2, beta 3. And this is such that these vectors satisfy the condition x1 plus x2 plus x3 is equal to 0. Now we are going to add these. So we get u plus v is equal to alpha 1 plus beta 1. We're adding them piecewise, add the x's. Alpha 2 plus beta 2, alpha 3 plus beta 3. And then when we look at this vector, we need to work out if this particular vector satisfies the conditions we're after. Well, if this is our vector, we can think of this in terms of three components. We've got an x component for the vector, a y component for the vector, a z component for the vector. So we can say that this is actually alpha 1 plus beta 1 plus alpha 2 plus beta 2 plus alpha 3 plus beta 3. We can rewrite this by grouping all the alphas together. This becomes alpha 1 plus alpha 2 plus alpha 3 plus beta 1 plus beta 2 plus beta 3 is equal to 0. And in fact this is true, because the sum of these variables was equal to 0, the sum of these variables was equal to 0. So this is true. So therefore we have closure under addition. So we have a 0 vector, we have closure under addition. Now the last thing we need to check for is closure under scalar multiplication. So for part 3, what we're going to do is we're going to set up some vector, let's call it u, and we're going to, we'll define this vector first. This will be alpha 1, alpha 2, alpha 3. Then we'll set up some constant, let's call it c. C is equal to c. So we get c times u. We've got c times u, remember c is a number, so this is a scalar multiple, is equal to c alpha 1, c alpha 2, c alpha 3. So this is our vector. Now this is the same as c alpha 1 plus c alpha 2 plus C alpha 3. We can factor C out. We get C in front of alpha 1 plus alpha 2 plus alpha 3, which we know is equal to 0. So this is equal to 0. And so this demonstrates that this has closure under scalar multiplication. So we have the 0 vector, we have closure under addition, we have closure under scalar multiplication, we have everything. So therefore, yes, cap X is a subspace of R3. And this is the answer that we're after.